Okay, hello. Right, what we're going to be doing is BNF, Backus Now Form, and Syntax Diagrams. Okay, this is going to be hopefully quite short, so let's have a look. Now, we won't be doing the exercises, I think, but I'll set you some work on that. Right, okay, so you've got the PowerPoint, you've got the summary. I'll talk about the summary at the end. Right, okay, so comparison with regex. So this is, again, a way of defining a formal language. But there's a problem with regular expressions. It does not allow a symbol to be grouped into classes. In other words, it's going to be extremely tedious defining a programming language in regular expressions. And I'll show you an example at the end of my first programming language using regex. Not regex, Backus Now Form. Right, now if you remember the language of the pencil, we've got, there it is there, but we could, it's not too bad to do in terms of regex because it's not a massive alphabet. But on this one here, we could break it up, lead hardness, into HB, scale of hardness, simple hardness, and then we have numerical values, simple hardness for H. Now, so that's breaking it down. Now, the rules for the language could be this. Now, we have these square bracket, angle brackets, if you like, there. That's what's called non-terminal symbol. And where that doesn't exist, so it means our lead hardness is defined as H followed by B, or scale of hardness, which is defined here, defined elsewhere, followed by simple hardness. So we have like an overall definition there, and then we can break that down further. All right, so this is where it comes in useful. So, as I just said, alternatives and non-terminal symbols defined as well. So the full definition would be this. So we have scale of hardness, a numerical value, followed by simple hardness. And again, there's a numerical value, 2, 3, or 4, and then our simple hardness is H or B. So think of 2H, is that a valid one? Well, it's not that. So scale of hardness, numerical is 2, and then followed by H, so that would be fine. H2 wouldn't work though. Right, so that's a nice way of defining your pencil language. Now, where it does become useful is it can be recursive. Now, so here's an example, unsigned integer. Remember, an unsigned integer always positive, so it could be a digit, or 2 digits, or 3 digits, or 4 digits, and so forth. Now, a digit is defined here as these values there. All right? Okay, obviously with digits we have to define each one of those, but that is, you can't expect people to keep adding more and more there for every digit that's possible to happen. So what we could have is this. Now, so we have, it's either a digit, an unsigned integer, or it's a digit followed by an unsigned integer. Now there's the definition for itself here. So there's the recursive definition. Remember, recursion is a definition that's defined in terms of itself or calls itself. So there is the definition there for a digit, and that will work for any length of digits. Now let's have a look at how that works. So let's see an example. 2, 3, 4 is an unsigned integer. Is it? Well, we know it is, but let's just go through it. So we would then do 2, 3, 4. We feed it in here. Is it a digit on its own? No. Is it a digit followed by an unsigned integer? Well, 2 is a digit. And then we then feed in 3, 4 as an unsigned integer back into itself. All right. So then we come in here. Is 3, 4 an unsigned a digit? No. But is 3 a digit? Yes. Is 4 an unsigned integer? Check it in. Is 4 a digit? Yes. So the answer is yes, 2, 3, 4 is an unsigned integer. Right. So this is basically what I've just said here. Okay. Now here's an example of defining a programming language. So you can say a statement is either an assignment statement, a for statement, an if statement, etc., etc. And then you've got an assignment statement is an identifier. Remember an identifier. An assignment operator, an expression. What's an assignment operator? Well, it could be the multiply operator, the add operator, and again, all of these are defined. So the add operator is a plus or a minus. and so forth. So you can, as I say, this was taken from one of my old, no, that's actually taken from the textbook, not one of my old textbook, the syntax diagram is. Okay, so there's defining a programming language. So you could define a programming language with that, so all the rules there. Now, let's have a look at the next one, which is syntax diagrams. Now these are incredibly easy. Sometimes called railroad diagrams I suppose that's more American. Now this was taken from my old Pascal textbook. So what do we have? We have, this is like your non-terminal here. So in a square box means digit is defined elsewhere. So we can have, imagine you're coming from left to right, you can either have a digit here, which is defined here, or you could just go around the points there and not have it. So a digit is defined as, is 3 a digit? Can I follow 3? Yes, it is. All right. So here we go. Here's my example for Pascal here. So they've non-terminals in the square bracket says. So program, that's the word program, you actually say that. So this is how you define a program. And identify, you have to give a program a name, then there's some brackets, and then you have an identifier, and you separate those with commas, and then you close your brackets, and it's semicolon, then your block of code is written with all your code in it. So does that make sense? And then you have a full stop to finish. Okay. Now, what is defined by this following syntax diagram? Pause the video and see if you can work that out. Well, welcome back from the pause, if you did pause it. Essentially what we have here is Roman numerals, 1 to 10. So can I have 10, which is X? Yep. Can I have 6, which is V1? Yep, I can, and so forth. All right, so that's quite a simple one to do there, isn't it? Okay. So the exercise there, draw diagrams that represent the following BNF rules. So we've got lead hardness, scale of hardness, and there's our one that we did earlier for the BNF. Okay, so give yourself a couple of minutes. Welcome back. Right, so there's my answers on there. Okay, so we have lead hardness, H followed by B, or it can be scale of hardness or simple hardness. Scale of hardness is numerical value followed by simple hardness. So remember the rectangles represent non-terminals, so that means they're defined elsewhere. All right, there we go. As I said, I'll set you some work on the previous exam questions on that, and fairly straightforward. Now don't get too worried with the BNF about the syntax. They will be fairly okay in the exam as long as you don't go too far away. Okay, that is that.